All right, so there's a couple of problems up there in the top left that I would like you to do on your own. 6 over 7 to the negative 1 means take the reciprocal one time, and 5 to the negative 3 means divide by 5 three times. I'm going to say that again. 5 to the negative 3 means divide by 5 three times. So you put 1 divided by, and then there's 3 5s on the bottom. But we need to talk about scientific notation next. And I really like this simulation for it. So I really like the intuition assignment on Khan Academy for this, because it's all about moving the decimal. So in scientific notation, the only number that I care about is the first number, and all of the other numbers are unimportant. So in scientific notation, I want to know where is the first number, which here is 9. What is the first number and where is it? Okay, so let's move the decimal after the first number. That's the only one that's important. And we'll figure out where it is in the decimal place by counting as I go. So I'm going to move the decimal 1, 2, 3 times. Now you can see that now that I have the decimal point after the first important number, then I have to divide it by 10 3 times. Let me say that again, and I'm pointing to it. The base here is 10. The exponent is negative, which means divided by, and the count is 3. So this says divide by 10 3 times. So these two numbers are equivalent. If you take this number and you divide it by 10 3 times, you get this number. All right, I'm going to move it back again to count. 1, 2, 3, so that's where it started. All right, so in scientific notation, I put the decimal after the first important number, and this is a negative exponent because I'm dividing by 10, and I moved it 3 times, so it's 9.288 times 10 to the negative third. All right, so this is just like the other problem, except this is a big number instead of a very small number. So instead of having to move the decimal point to the right in order to get it after the first important number, I'm going to need to move it to the left so that it's after this 7. Now, the count is the number of digits that come after the 7. So I'm going to write something that says 7 followed by 1, 2, 3, 4, 5, 6, 7, 8 digits. Okay, so I'll move the decimal, and I now have in scientific notation, this is 7 followed by 8 digits. So 7 times 10 to the 8 because there's 8 digits after this 7. Okay, so let's practice the actual assignments doing that. All right, here's the first one. The first one here is a decimal. It's a very small number, and so I move the decimal point to the right. And that means I'm dividing by 10, not timesing by 10. So this is equal to 5.937, because I moved the decimal point after the 5, times 10 to the, I had to divide by 10 3 times in order to get that happen, so it's 10 to the negative 3. Okay, what about this one? This is a 4, and it's followed by 9 digits after that. So there's a 4, the most important number is 4, and after the 4, there's a total of 9 digits. So let's count. After the 4, there is 5, 9, 4, so that's 3 digits. 0, 0, 0, 0, 0, 0. That's 9 digits. Okay, let's count again. What this says is 4 times 10 to the 9th. In other words, it's a 4 in the billions place. So that's 4 followed by 3, 6, 9 digits. So to write this number in regular number, it's 4 billion. All right, so this was a small number that I divided by 10 because it's a negative exponent, and this is a big number because I'm timesing by 10. All right, let's practice again. This is the number 8. The number 8 is followed by how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's an 8 here in front, and then that's followed by 11 digits. So that's 8 times 10 to the 11th. Now, if I wanted to be more accurate, I could include the 9, the 0, and the 1. 9, 0, 1. But the only thing that matters is the 8 followed by 11 digits. And then I need to talk about this fractional exponent in a second. All right, so this is a fractional exponent. So we talked about regular exponents. Regular exponents like, say, 2 to the 3rd, that's pretty easy. It just means there's 3 2s. Negative exponents, a little bit more confusing. A negative exponent means divide, not times. So that's divide by 2 3 times. Okay, so negative in the exponent means divide, not times. And then there's also another possibility, and that's fractions. A fractional exponent means either square root or cube root or something like that. In other words, it's the inverse of a square. So 2 to the 1/2 means square root of 2. 2 to the 1/3 means cubic root of 2, and so on. 2 to the 1/4, means fourth root of 2. So you're looking for what's inside 2 4 times. And I just wanted to quickly remind you what a cubic root was. We started out by talking about those. You're asking the question when a cubic root, you're asking what's inside there 3 times. So for example, the cubic root of 729 is 9. So another way of writing that would be 729 to the 1/3 power. Okay, 1/3 is the same thing as a cubic root. This means cube root. Cube root. Okay, so just again to review, exponents count how many times you times, negative exponents count how many times you divide, or another way of saying that is reciprocal. Fractional exponents are either square roots or cube roots or fourth roots or something like that. In other words, they're inverse functions to squares and cubes. Okay, so this is 125 to the negative 1/3. So let me clear this off. The negative here means divide, and the 1/3 here means cube root. So there's a lot of details in these kinds of problems. Exponents, as soon as you see this problem, I mean, don't think of it as being really confusing. Think of it as being, oh my goodness, these exponents are really powerful. They contain a lot more meaning than I thought they did. So they can actually tell you to divide by a cube root just by writing down an exponent. All right, so I would need to divide by the cube root, which looks like this. What am I doing? I'm dividing, because the exponent was negative, the cube root, because this was 1/3 of 125. Now, the cube root of 125 is, of course, 5. So this is 1 over 5. I'm going to repeat that again. Divide, because of the negative, so 1 divided by, the cube root, because it's 1/3 of 125, and that's equal to 1/5. I only have a couple of minutes left. I'm going to need to kind of rush through these. So this one is 9/4 to the 1/2. Now, an exponent that's fractional like this is 1/2, and that means the square roots. Right? So I can rewrite that as the square root of 9 over 4. And the square root of 9 is 3, and the square root of 4 is 2. So the only thing you needed to care about was that a fractional exponent meant square root. The rule for timesing two exponents like this is to add the two exponents, 8 and 10. So when I'm timesing two powers, I have to add the exponents, 8 plus 10, to make 18. But if I have parentheses like this, the rule is to times. So this is not 8 plus 10, it's 8 times 10. And 8 times 10 is 80. All right, now I have a table here that I can look for a pattern for, and let's fill out some things that I know are true. I know that 6 to the 0 must be 1 because I did not multiply it by 6. I didn't do anything to it, so that just leaves it as 1. Let's see if I can remember 6 squared is 36. If I write down the number 6 one time, it's just 6. Maybe somebody can remember that 6 to the 3rd power is 216. Okay, and then these, oh my goodness, they're negative. That must be confusing. No, negative exponents just mean divide. Okay, so I divide by 6 one time. It looks like this. 1 divided by 6. I divide by 6 two times. It looks like this. So that's just 1 over 36. And then if I divide by 6 three times, it looks like this. What is this? All I'm doing is I'm looking at this and I'm saying what I said, what it means. This means divide by 6 3 times. So I'm dividing by 6 3 times. And that's 1 over 216. But I just proved what I meant, what I said to you earlier, which is that divide means reciprocal. Because if you notice, 6 to the 3rd is the reciprocal of 6 to the negative 3rd. Okay, so negative exponents mean divide, and that's the same as reciprocal.